Hey everybody, here are two questions from the assignment answered to make it easier for you. The first question is a point P1 is located by the vector A, which is 3.76i plus 1.72j. And a point P2 is located by the vector 1.54i plus 3.76j. The vector C locates the point P2 relative to the point P1, and you have to find the vector C which points from P1 to point P2. So you're given two vectors whose endpoints are P1 and P2, and you're asked to find the vector which connects the endpoints. So that is the deal. And to get to the answers are of course shown here, but let me tell you how to get to the answer. This diagram should make it clear that you have P1 and then you have P2. So the points are P1 and P2, and you're actually asked to find the vector that connects P1 to P2, which is C. So you have vector A, vector B, and you're asked to find vector C. If you look at this diagram carefully, you can see that vector A plus C should give you B. So that's what is written here. A plus C gives B. But since you're asked to find C, you make that the subject, and that gives you B minus A. So all you got to do is take the difference or take away A from B, which is what is done here. So you have 1.54i plus 3.76j minus the other vector. So you subtract the I from the I and the j from the j, and you would get the answer. So that's what's given here. And then to find the magnitude, all you got to do is add up their squares and take the square root. So that would give you the absolute value or the magnitude. So that's the absolute value or the magnitude. And to find the angle alpha, all you got to do is take any ratio, sine, cosine, or tan, in this case, you could find alpha by using cos inverse Cx by C. All right. Now, since that's given us alpha, you take Cx and divide it by C. So in this case, Cx would be this way. Sorry for that. Cx would be this way, Cx, right? Take the x component, and then, all right, let me show you how that is done. So as you can see, the magnitude is given there. As you take the sum of the squares and take the square root, you get that answer. And then to find the angle, you take the x component of the vector. You know why that is negative, because it's along the negative x-axis. So I need to go back and tell you that the x component is going to be this way, right? So that's why it's negative. And so the negative of the x component divided by c will give you the angle, which is 137 degrees. And then the last part, to find the unit vector, you know that the unit vector has a magnitude 1 and it only gives the direction. So what you got to do is take the vector itself that you've got, vector c, and divide it by its absolute value. Or I mean its magnitude, the absolute value, right? So that's the vector and divided by its magnitude. That'll give you the unit vector. And now I hope that's clear. This is a second question. The polar coordinates of 2 points are given, and they are 2.90 meter, 40 degrees, and then 4.5 meter, 110 degrees. Now, this means, right, let me make a diagram. This means that if you have the x and the y, you've got to locate a point 2.9 meter away from the origin, making an angle of 40 degrees with the x-axis. So kind of this way, let's say 2.9 meters. So that is point 1. Means this angle should be 40 degrees. And the distance here is 2.9 meter. That's this distance is 2.9 meter. Now for the second one, likewise, the point 2 is 4.5 meter away and at an angle of 110 degrees. So since it's at 110 degrees, let me do this. So we got to go to the negative side of the x-axis, which means that the second point should be somewhere like that. So that's, it's longer. It's like this. So this total angle here becomes 110. Let me write that down here. 110. And this distance is what? Is 4.5 meter. So that is what is given there. Now to do that, as illustrated below, you can see that you have to break up the vectors along the x and the y. So for the first one, you have x1 given here as 2.9 cosine 40, because it's going to be the adjacent side, right? Because you're looking for this side now, 2.9 cosine 40. And then you take this, will give you the y component, which is 2.9 sine 40. Do the same for the other vector, but remember that when you take the x component, that's going to be negative. So that's why you have negative 1.54. And then the y component is, of course, positive. Once you get that, you take the difference. If you take the difference between the x, you will get the x, the change in x, and likewise for the y. So that is what is shown here. You take the difference between the x and the y, and then find the length by summing their squares and taking the square root. So that's how you get the answer to that. Now to find the direction of the line from point 1 to point 2, you just divide delta y by delta x, because the difference in the y and the difference in the x, so that sets up a right angle triangle, and the opposite side divided by the adjacent side becomes tan theta. So you do that, you get that, and you see that it's a negative. So to get the actual angle, which is in the second quadrant, you got to add 180 degrees to that. So when you add 180 degrees to that, you will get the answer as 148 degrees. So that is the answer. Thank you.